Hello students, welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher, and today we are going to do concept plus previous year questions of chemical bonding. So two very important concepts we are going to do today, that is VBT and CFT and dipole moments, extremely important, right? Why? Because these are like for sure to be asked in your exam. You can also see jee-mains attempt 1, you can see directly the question they are asking is from this VSEPR hybridization VBT. It's a combination where they ask you shapes, hybridization, right? And next is MOT, right? That is molecular orbital theory. So in molecular orbital theory, if you talk about directly, the questions are asked, right, based on the bond order, right? So everybody let me know in the comment section if I am clearly visible and audible to you so that we can start with the class. Okay, so here let us talk about the first thing here, that is first thing first is let us talk about the VSEPR theory. So now if you talk about VSEPR theory here, let us talk about VSEPR theory. VSEPR theory is nothing but when we are talking about that, okay, orbitals are actually, you know, how chemical bonds are making, how we are making the chemical bonds. So VSEPR theory states that because lone pairs are unshared electrons, that is why they have a kind of repulsion between them, right? So the theory predict that the shape of the molecule by considering the most stable configuration, right, which is the most stable configuration that they are going to predict. And this theory, the most important point is that it says that lone pair repulsions are maximum. After that you have lone pair bond pair repulsions, then minimum you have bond pair repulsions. And we are going to do all of this with the help of these molecules so that you are able to understand the core concept of the chemical bonding, right? Okay, so that you can actually imagine. There is no imagination, you can actually see the shapes yourself, right? Now, next thing about VSEPR theory is that firstly I'll tell you individual theories and I'll mix them together, right? So if you talk about VSEPR theory here, they are talking about the electronic repulsions. Now, if you talk about these two molecules, this is one lone pair, this is having two lone pairs, right? Because of lone pair bond pair repulsion, here the angle is 107, right? Here you will have one more hydrogen, okay, there will be one more hydrogen. Here you have two lone pairs, so there will be repulsion of lone pair, and here there will be repulsion of bond pair. Because of this high repulsion, the angle has decreased to 104.5. In tetrahedral, the angle is 109 when you have all the four bonds, like CH4, like you have CH4. When you have one lone pair, the angle has decreased to 107. When you have two lone pairs, the angle has decreased to 104.5. That is how the angle is decreasing here, right? Order of repulsive interactions. If you see the order of repulsive interactions here, first is lone pair repulsion, then lone pair, bond pair repulsions, right? Okay. Now we are going to predict the geometries, right? So we are going to consider two types of things. Firstly, we are going to consider a molecule which has no lone pairs. Then we are going to consider the molecules which are having the lone pairs. So firstly, we will talk about the kind of molecules which have no lone pairs. So everybody will start it one by one. First thing is when you have two bond pairs, right? When you have two bond pairs, let's say this is the thing that we are talking about. This is the central metal atom, right? Let's say it is A and you have two B molecules around it. So that will have a linear shape. We are considering that it does not have any lone pair. So this is also bond pair, this is also bond pair. So it will show us a linear shape. Firstly, I am going to tell you only about shape. I am going to mix that in the end, right? First, you just go through the shapes only. Then if you have three lone pairs and bond pairs, then what we are going to make here, just give me a minute. See, this is actually called trigonal planar, right? This is called a trigonal planar. So what we are going to do here, here in one triangle form, you will have other three things, right, that are attached to each other at 120-degree angle. That is called trigonal planar, right? This kind of shape is called trigonal planar, right? Then next is what is tetrahedral. If you talk about tetrahedral, this is called tetrahedral shape. When this is at 109, this is at 109, all the angles are at 109 degree with each other. You can reverse this also, you can do this also, you can reverse this also. So all the things are actually symmetrical with each other, right? So that is called tetrahedral angle that has 109.5 degree angle. Next we have is trigonal bipyramidal. So in trigonal bipyramidal, basically what happens here, you have a, let's say you have a trigonal plane, right? Okay, so I'm going to make a trigonal shape firstly, right? Okay, that is the trigonal shape that you will have, right? This is the, I would say, not trigon, wait a minute, this is trigonal bipyramidal, na? Okay, so let us see what is basically trigonal bipyramidal. Let me just show you that. Just give me a minute. I'll just show you that. Okay. See, here you have this thing. Trigonal means a triangle, right? This is a triangle. And bipyramidal means here you have forming a pyramid, right? And here you are forming a pyramid. That is trigonal bipyramidal, right? That also is trigonal bipyramidal. Next is octahedral. So when you have 6 lone pair plus bond pair, that shape is called octahedral. So what is basically octahedral? When you have 4 angles that are at 90 degree, then there is one above at 90 degree with all of them and one below. That is called octahedral angle. Can you see? That is called octahedral, right? It has 8 phases. That is why it is called octahedral, right? Now, once you have discussed the shapes here, last one, I can't make it in 3D over here because I don't have that particular atom, right? But here, what exactly? Just like you had trigonal bipyramidal, here this is called pentagonal bipyramidal. Pentagonal bipyramidal means like here you had one triangle. In this case, you have one triangle, 3 atoms. But in this case, you will have 5 like pentagons. You will have 5 atoms around this, right? And one pyramid above and one pyramid below. That is called pentagonal bipyramidal, and the example is IF7, right? Next, let us talk about the next thing here. Let us talk about the lone pairs. If it also has the involvement of lone pairs. Now one by one we will talk about how lone pairs affect this, right? So firstly, let us talk about the first thing here, that is if you have linear shape. Chalo, linear to I'll tell you about linear shape as well. If you have linear shape, then what will happen, right? Okay, this is the linear shape. Okay, can you see this is the linear shape? Now, if you talk about this linear shape here, if I say one atom, I'm one bond pair, I'm substituting it by one lone pair, right? That is called, that is also now, even now it is a linear shape, right? So even if you have one lone pair or even if you have 2 lone pair, the shape is going to remain the same. That is linear only. Now always remember that whenever we are talking about, always remember one thing, that whenever we are talking about geometry, whenever we are talking about geometry, we are talking about lone pairs plus bond pair, or I'll say LP plus BP. But when we are talking about shape, when we are talking about shape, we are only talking about the bond pairs here. We are just ignoring the lone pairs here, right? Okay. Now, let us see this. If you have trigonal planar, in trigonal planar, if I say this is trigonal planar, right? Can you see? Now, in trigonal planar, I am saying that I am going to replace one bond pair with the lone pair. This is the trigonal planar geometry. Here I have one lone pair. But when I am talking about the shape here, I need to ignore the lone pair. So now it is a bent V shape. It is bent V. This is V, right? So it is bent V shape. So answer will be bent V shape, right? Next is, let's talk about the tetrahedral here. So if you talk about the tetrahedral, you replace one lone pair with the bond pair. I have replaced it. Now what I have? Can you tell me what is this? I have replaced one lone pair with the bond pair. What is this? This is a pyramid, right? So the answer is trigonal pyramidal. Trigonal because you have 3 bonds. Trigonal, it is not trigonal planar. Trigonal planar is like this, okay? The difference between these two things. Let us see the difference. When you don't see the angle, you will say, ma'am, both are same, right? This is trigonal planar, right? This is in one plane. Can you see? This is in one plane only, right? This is in one plane, right? And what about this one? This is not in one plane. This is not in one plane. Can you see? This is not in one plane. So this is trigonal pyramidal, right? Next we have is if you have tetrahedral and you're replacing 2 atoms here. In tetrahedral, you're replacing 2 atoms with the lone pairs, right? This is the tetrahedral, right? This is the tetrahedral. You're replacing 1 and 2 bond pairs with the lone pairs. In the shape, you have to ignore the lone pair. So this is nothing but this is bent V, right? So here answer is going to be bent V. Next we have is trigonal bipyramid, right? So this is the shape of trigonal bipyramidal. Yes, everybody, are you liking this? If you're able to understand these things, trust me, have patience, right? If you listen to all of this patiently, I can guarantee not even a single question in jee-mains, you will be like, yes, ma'am, I can easily solve this because all the things are in your head. That's why from the basic I am starting here, right? So this is a trigonal bipyramidal, right? Now here you are going to replace one lone pair with the one bond pair with the lone pair. Now can you tell me what is this? This is trigonal. This is the trigonal. And this is one pyramid over here. So this is trigonal. One thing. Oh, what we did wrong, ma'am? What we did wrong? This is the axial position, okay? This is the equatorial position. Whenever we are replacing bond pairs in trigonal bipyramidal geometry, you have to replace from the equatorial position. Now, can you see it is a seesaw shape? Can you see? It is a seesaw shape. Everyone, can you see that it is a seesaw shape? Right? Can you see that? Can you see that? It is a seesaw shape, right? Just like the seesaw, right? So here answer is seesaw. Next is when you're going to replace 2. Now, as I told you, bond pair is replaced from equatorial position. So one from here, one from here, and now what we have is T, right? So answer will be T shape. Understood? Next is you have octahedral. Now in octahedral, this is the case, right? This is the case in octahedral. Now tell me one thing. If you're going to replace, now here all are like equal only. You can replace from here, from here, from here. That is only in the case of trigonal bipyramidal where you have to replace from the equatorial. Others, there is no as such thing, right? So here I replaced it from this side. Now it is square pyramidal. Can you see? This thing is square. This thing is nothing but it is square. And this thing is one pyramid over there. So it is square pyramidal, right? Okay. Next is when you replace 2 octahedral. Now, if you have replaced it from this side, the opposite bond pair will be replaced to maintain the stability of the structure. Now, this is nothing but it is square planar, right? So, answer here is square planar. Got it? I think now you have an idea, like clearly, not even idea, you have a clear image in your head that what is octahedral, square pyramidal, everything you know. Now you don't need to cram anything here, right? Okay. Now I'll give you a hint of hybridization, and after that we are going to mix it and we are going to see how to solve the question based on VSEPR hybridization, right? And the shapes and geometries based on that, right? Okay. Now let us see the shape of molecules containing lone pairs and bond pairs. I'm just giving you one hint here, right? This let us do this in the end only. Okay, let us, why I'm telling you, because I want you to do this with the help of my trick. Okay, firstly, let us do the hybridization so that we are also able to, from these example, we will calculate that why that was the shape. Everything I'll tell you, right? Now see hybridization. Hybridization is the intermixing of orbitals to have hybrid orbitals, right, which are of the same energy, right? Now, there are so many types of hybridization: sp, sp2, sp3, dsp2, d2, sp3, sp3, d2. So many types of hybridization there are in our syllabus, right? So, I'll just tell you what shape you're going to get where. When you have sp, you will have linear shape, right? Linear geometry, I would say. I'm telling you about the geometry. That's what I told you. From the hybridization, the important part is to connect hybridization with the geometries, right? SP is linear, SP2 is trigonal, planar geometry, SP3 is tetrahedral geometry, right? Okay. DSP2 is square planar. That is usually not, that we usually use DSP2 in d orbitals. That is in coordination compounds, we will use DSP2, right? Because here we are not doing transition elements, right? Okay, so that's why. SP3D, you don't have to focus on that because that is not that much in your syllabus. DSP3 is also not. SP3D2 is in your syllabus, that is octahedral. That is octahedral, right? Okay, understood? Now, SP3D2, I have not written any, SP3D. Acha, SP3D is here, right? Okay, so I'll just write it here. SP3D, you can write here, it is trigonal, bipyramidal. Bipyramidal. Okay, I thought it is SP2D, right? So these are the things that you have to remember, right? That this is linear, trigonal, planar, tetrahedral, trigonal, bipyramidal and octahedral. These are what we will use in chemical bonding, right? We will use all of them in chemical bonding here, right? Now, this thing is not at this point of time, they will not ask you this like how hybridized orbitals are made, right? You just know that these are made from intermixing. We will do the application part, right? Okay. Application part is here. Don't worry, I am not skipping any slide here. Ma'am, we are skipping slide, ma'am. Please, ma'am. Why, ma'am? I'm not skipping any slide. I'm telling you that this is how we are going to learn things. This is how we are going to understand things, right? Firstly, we understood that there is hybridization. I'll also make one table here for your easiness, right? For your easiness, I'm going to make a table so that from the notes only you're able to understand. SP, everybody, I want to see that in the comment section. SP2, SP3, SP3D, SP3D2. Okay, these are what you will use in chemical bonding. This is linear geometry. This is trigonal, planar. This is what you have to remember from hybridization. Then this is tetrahedral. Next is trigonal bipyramidal. Bipyramidal. Next is last one, everybody. Octahedral geometry, ma'am. Now, from this and from that, we are going to solve the questions, okay? And those examples that I have left, we will solve that also. Now, let us see this. Hybridization, how you will calculate. That is the main part. Ma'am, here you have written SP, SP3, ma'am, but in the exam, who will tell me, right? So, let us see in the exam how you will solve it, right? In the exam, how we are going to solve it. Let us see. We know that beryllium, hydrogen, helium, lithium, beryllium. It is atomic number 4, right? And this is BeCl2. That means chlorine is definitely bonded with a single bond here, right? It cannot be like B positive, Be and Cl are not bonded with any covalent bond. There must be some bond here. So that means I can say that out of this 4 electrons, 2 are already, or I would say out of the 4, you can say it is 1s2, 2s2. So outermost shell, you have 2 electrons. And in all the cases, you just have to see the outermost electrons. What I am saying, always see the outermost electrons. You can directly see the group and see the outermost electron. For example, if I say this belongs to group number 2. So outermost electrons are 2. and all the two electrons are involved in the bonding, so there will be 0 lone pairs, right? That means lone pair plus bond pair is going to be 2, right? Now here, ma'am, how can from here you can tell the hybridization? One more thing you draw here, one more thing you draw here, that is, here it is 2, 3, 4, 5, 6. What is this? Lone pair plus bond pair. If lone pair plus bond pair is 2, sp, 3 sp2, 4 sp3, 5 sp3d, then sp3d2. Understood? Now, here we can see that lone pair plus bond pair is 2, so hybridization is sp, right? Okay. Next is BF3. Beta, this is very important what I am telling you. Right now, so you will be feeling, ma'am, boring, ma'am. But in the end, you will feel that how questions are getting solved here. Boron belongs to group number 30. Now here, we know that it has 3 outermost electron because it is belonging to group number 13. So 3 outermost electron, 3 surrounding atom it has. That means at least 3 bonds, so definitely it is forming 3 sigma bonds. So it will be 3 which are occupied, that means you will have 0 lone pair. So lone pair plus bond pair is 0, bond pair it is forming 3, so it will be 3. So answer is, wait a minute, it should be sp2 not sp3, here it should be sp2, right, not sp3. Understood? Next is SO2. Now let us see, ma'am, SO2, ma'am. How to solve this, ma'am? Multiple bonds. I'll tell you how. See. Sulfur belongs to which group? Sulfur belongs to group number 16. That means the outermost electrons are 6. We know that oxygen, if it does not have any negative charge here, right, then it is forming multiple bonds, right? So that means, can I say SO2 must be something like this? I'm just drawing randomly here, double bond and double bond. Because if oxygen is not negatively charged, it is definitely in a single, it is definitely a double bond, right? So here it is a double bond, right? So this is 6 minus, we know that how many bond pairs are involved here? How many bond pairs? 1, 2, 3, 4. That means 4 electrons are involved in bonding, right? Bond pairs. So 2 electrons we are left with. Those 2 electrons are the lone pairs here. Those 2 electrons are the lone pair that we have drawn here. Now, ma'am, it has, ma'am, 4 bond pairs. 2 lone pairs, ma'am. 1 lone pair, sorry. Ma'am, then it should be 5. Why it is 4? Now see one thing, that when I am writing this here, I am talking about lone pair plus sigma. How many sigma? Not pi. How many bond pairs in sigma bond, not the pi bond. That's why when I draw this, this is 1 sigma, 2 sigma, 2 plus 1 lone pair, that is, wait a minute, 2 plus how many? Lone pair. Lone pair is 1, right? Yes. It should be sp2, I am written sp3, sp2 it should be, right? So it is total 3. 3 means it is sp2. sp2 means it is trigonal planar. So that's why this is the structure of SO2. Got it? Next is PCl5. Phosphorus belongs to group number 15, right? Phosphorus belongs to group number 15. In this 15 group number, minus 10 you do, that means 5 outermost electron you have, right? You have 5 surrounding atoms, that means at least 5 bond pair it is forming, right? So 5 minus 5, it is going to be 0, that means there is no lone pair, right? Lone pair plus bond pair, lone pair is 0, bond pair we have 5 bonds here with chlorine is 5, so answer is going to be 5. And for 5, the answer is sp3d, that is trigonal bipyramidal. That is why this is the structure of trigonal bipyramidal, right? This is the structure of trigonal bipyramidal. Is that clear? Is that getting clear in everyone's head that what we are doing here, right? That is why it is trigonal bipyramidal, right? Next is NH3. Again, how to calculate this? Now, NH3, nitrogen belongs to group number which? Group number 15. Group number 15. That means outermost electrons are 5. Let us write 5 here. Done. Outermost electrons, group number 15 is 5. Nitrogen, phosphorus, everyone has 5 outermost electron. Now the surrounding atoms are 3. 3 hydrogens. That means only 3 bond pairs you will have here, isn't it? Only 3 bond pairs you will have. Out of this 2 electrons you are still left with. One lone pair has 2 electrons. That means 1 lone pair you have. 1 lone pair, bond pair are 3. That means total 4. 4 means it is sp3, right? sp3 means it is tetrahedral geometry. But is the shape also sp3, everybody? Is the shape also tetrahedral or not? Anybody in the comment section? Is the shape also tetrahedral? Geometry I am saying is tetrahedral. Is the shape also tetrahedral? Geometry is tetrahedral, but here you have 1 lone pair. So the shape is trigonal pyramidal. So I'll just write it here. The shape will become trigonal pyramidal. Trigonal pyramidal. Okay? Understood? Understood? Next. Here it is BeCl2. I think this we have done. Okay. Next is SF6. Everyone. Next is SF6. Now in SF6 what you have? Everyone. SF6 sulfur belongs to group number, ma'am. It is group number 16. 6 outermost electron. Out of these 6 outermost electrons, 6 fluorines are attached. That means 6 minus 6 is equals to 0. That means 0 lone pairs, right? But lone pair plus bond pair, that is 0 plus 6. How many bond pairs? 6. So it is 6 only. 6 means sp3d2. That is octahedral. That is octahedral, right? So here what you will draw? Octahedral. That is, you will draw this particular geometry SF6, right? You will draw this particular geometry SF6. That's why I'm saying it's a very interesting chapter. It's a very, very interesting chapter. SF6, right? Next, XeF2. Xenon belongs to which group? Anybody in the comment section? Xenon belongs to which group? Anybody? Xenon belongs to noble gases. Group number 18. 8 outermost electron. It is bonded to 2 fluorines. Fluorine can form single bond. It's not like with oxygen it can form double bond, but with fluorine it can form single bond. That means 2 electrons are involved in bond pair. Out of this 6 electrons are left. 6 electron means 3 lone pair, because 1 lone pair has 2 electrons. So lone pair is 3 plus bond pair is 2. Answer will be 5. That means it is sp3d. So the geometry is trigonal bipyramidal. Geometry is trigonal bipyramidal. But here you have 3 lone pairs, and lone pairs we attach it on the equatorial position. 1, this is 2, and this is 3. Now what you will have is this thing that is linear, which has 3 lone pair attached here. So here answer, if I say lone pairs, I am representing by green. So basically these are going to be lone pairs. Okay, I'm telling you, if I represent lone pairs by green, then these are the lone pairs. This green are the lone pairs. This white are the bond pairs. Understood? Now here you can say the shape here is linear, because in the shape we don't consider the lone pairs, right? Okay. Next, AsF5. Now, again, arsenic belongs to group number 15, right? For this, you need to have periodic classification. You need to have periodic table in your head. Group number 15 means 5 outermost electron. Out of this 5 fluorine it is bonded to, that means 5 electrons are involved in bond pair, 0 lone pair. 0 lone pair plus 5 bond pair comes to 5. 5 means sp3d, that means it is a trigonal bipyramidal geometry where all the there is no lone pair, so answer will be this particular thing. Right? Understood? Is there any problem till here? Now I'll tell you what are the things that I skipped here. Right? What are the things that I skipped here? If there is any problem till here, then let me know in the comment section so that we can, if there is anything needed, we can, I can again teach you that. Right? Okay, students? Okay. Now, if you see this thing here, shapes of molecule containing lone pair and bond pair. Lone pair and bond pair. Can you see that? Everybody? Huh. Okay. Now, SO2 we have already done. I have told you this. This too we have done. NH3 we have done. Okay. H2 we have not done. Let's see this. Right? Very simple. Oxygen belongs to group number 16. That means 6 outermost electron. 2 hydrogens are attached, that means 2 bond pairs, 2 electrons involved in bond pairs. Out of this you have 4. 4 electrons are unshared, that means 2 lone pairs. 2 lone pair plus 2 bond pair, it comes to 4. That means it is sp3 hybridization, right? And in this you will have 2 lone pairs, right? That is why the geometry is going to be tetrahedral, but the shape is going to be bent V shape, right? Okay. Then SF4 have we done or not? I think we have not done. Achha, this we have done SF4, right? Sulfur belongs to group number 16. It has 4 bond pairs, so it is 2. 2 means 1 lone pair, 1 lone pair. 1 lone pair plus 4 bond pair, it comes to 5. 5 means sp3d, that means trigonal bipyramidal. In trigonal bipyramidal, in this case, you are just making 1 bond pair to 1 lone pair. So that bond pair will be on that lone pair that you have will be on the equatorial position, right? So that is why if you see the shape will be seesaw shape, right? So that is why it is a seesaw shape. Got it? Understood? I think all the other concepts are clear in your head now because we have done all these things in detail, right? This also we have done SF6, right? This also we have done PCL3, PCL5, right? Now let us start with the questions, right? That they can ask you, that are the previous year questions of JEE, right? Let us see the previous year questions of JEE regarding this. First is molecular shape of SF4, CF4 and XCF4, right? So how to answer that? Same way that I have told you now. Same thing we will do here. First is SF4. Sulfur belongs to group number 16. It is 6 minus, this we have done just now. Minus 4 electrons are involved here. 2 means you have 1 lone pair. Lone pair plus bond pair is 1 plus 4 bond pair, it is 5. That means it is sp3d. That means here the shape of SF4 is going to be 1, 2, 3, 4, 5, 6. That is the geometry is trigonal bipyramidal. But you have to replace 1 bond pair with lone pair. So this is going to be the shape, that is seesaw. Right? So molecular shape of this are they are saying the lone pair. Different with this, different, same, right? Shapes are going to be different only because this has seesaw shape. CF4, if you see, CF4 will be carbon belongs to group number 14. So it is 4 minus 4 bond pair, it is 0. So lone pair plus bond pair is going to be 0 plus 4, that is sp3, that is tetrahedral. So it is C1F, other F, other F, other F. So it is tetrahedral. So they are going to be different here, right? If you see XCF4, xenon is nothing but xenon. If you see, everybody, what is xenon? Xenon belongs to which group? Xenon belongs to group number 18. So it is 8 minus 4 electrons are involved. 4 you are left with. That means 2 lone pairs. Lone pair plus bond pair. Lone pair is 2, right? Lone pair plus bond pair is going to be what? This is 2 lone pair. Bond pair is what? Bond pair is what, everybody? 2 lone pair. Bond pair is 4. So it is going to be 6. That means it is sp3d2. That is octahedral, right? But you have 2 lone pairs. So here the answer will be Xe1, 2 lone pairs, 1, 2, 3, 4, 4 bond pairs. So this is square planar, this is tetrahedral, this is seesaw. Different we have, this has one lone pair, okay. This has 1 lone pair, this has 0 lone pair, this has 2 lone pair. So 1, 0, 2 is the correct answer. So answer is D is the correct answer. Okay, that is how you're going to solve it, right? Okay, now next we have the incorrect shape is represented by which thing, right? Incorrect shape they are saying. So if you talk about the shape, incorrect shape here, the answer will be this is B, right? Easily, so you will be able to learn this only. Now so it will be on your tips only. But still, if you're like, ma'am, please teach me this, I'm not able to understand, then for those students, I'll tell you that in detail. See, boron belongs to group number 13. It is 3 minus 3. It is 0 lone pair, right? So, lone pair plus bond pair is 3. So, it will be sp2. That is trigonal planar, right? So, this will be the shape. That is trigonal planar. That is correct, right? NF3. Nitrogen belongs to group number 15, means 5 outermost electron minus 3 bond pair, it is 2. That means 1 lone pair you have here, right? 1 lone pair plus 3 bond pair, it is 4. That means it is sp3. So its geometry is tetrahedral. That means here you will have N and 1, 2, 3, 4. But out of this, 1 bond pair is replaced by the lone pair, right? So here it is replaced by the lone pair here, right? So what is the geometry that you have? Tell me. This kind of geometry, na, when in a tetrahedral, 1 lone pair is replaced by the bond pair, right? You have a, what is this? This is trigonal pyramidal, right? So the geometry has changed, right? So this is not trigonal planar. That is incorrect, right? That is incorrect. This is trigonal pyramidal, right? Trigonal pyramidal, right? That is the answer. Next is ASF5. We have just done that. This is trigonal pyramidal. H2 also we have done. That is a bed shape, right? So answer will be B is the correct answer and the incorrect option, right? Oh, sorry, correct option and which is not the correct shape, right? Okay. Next is, in a bonded molecule, the order of repulsion between the bonded and non-bonded electron is. Bonded and non-bonded electrons we are saying. The order of repulsion between bonded and non-bonded. One is bonded, other is non-bonded. So if you see, simple, that is lone pair, then lone pair, then bond pair, bond pair. So answer is C is the correct option, right? Next is the bond angle in BF3. BF3, what was the bond angle? It is trigonal planar. In trigonal planar, what is the bond angle? It is 120 degrees. So answer is A is the correct answer. Next question on your screen we have, as a result of sp hybridization, sp means when you have lone pair plus bond pair or lone pair plus sigma is 2, sp, that is A, this is B, this is B. So here the angle is 180 degree. Two mutually perpendicular, no. Two orbitals at 180 degree, that is correct. So answer is B is the correct answer. Okay. Next question, guys. Everybody try to answer this. Which of the following statement is true about hybridization? Which of the following statement is true about hybridization? Only those atomic orbitals can be hybridized which do not differ much in shape, right? Only those orbitals, they are saying, which is true. Only those orbitals can be hybridized which do not differ much in energy. Only those orbitals hybridized which do not differ much in size. Only those orbitals hybridized do not differ much in, which do not differ much in overlap integrals, right? Okay, everybody, which statement out of this is true? Now here we have four concepts: shape, energy, size and overall integrals. One thing is definitely all of them matters, but which matters maximum? That is the energy. Because in energy, if you say 2p and 5d, no, they will not be able to overlap. Because of the energy, right, the size also differentiates here. So the accurate answer will be B, right? Next question is, the state of hybridization in the central atom is not the same as in the others. The state of hybridization central is not the same as, okay, you have to see the state of hybridization here. In boron, same thing, beta, same thing. Boron belongs to 3, group number 13. 13 minus 3, 3, sorry. Group number 13 means 3 outermost electrons, 3 bond pair, it has 0 lone pair. Lone pair plus sigma bond is 3. So it is sp2. Okay. This is, if you talk about this, you have H3O positive. Is it NH or NH? Wait a minute. It is NH3. It is NH3. Okay. Right? Now, let us talk about H2O. This is H3O. Okay. Now here, we know that a sentimental atom is oxygen. Oxygen belongs to group number 16. That means 6 outermost electron it has. Now, out of those 6 outermost electrons, we know that 3 are already involved in the bond pairs. That means you are left with 3. Right? Now here, can you tell me one thing? That basically what is happening here? What is happening here? This is H2O, this is oxygen, this is H, this is H, this is one lone pair, this is one lone pair. Right? If you talk about this particular thing here, and you are adding one, there is one hydrogen that is further attached, and here you have positive. In this case, what you will have in the end is 3 sigma plus 1 lone pair. That means it is eventually is going to be sp3 only, because one lone pair is occupied in bonding with hydrogen, right? So it is going to be sp3. Here in this case, it is going to be again sp3, right? So again, nitrogen is one lone pair, 3 bond pair. This we have already done before. sp3, right? Here it is PCl3. PCl3, if you see, phosphorus belongs to group number 15. That means 5 outermost electron. 3 are involved in bonding. That means it has one lone pair. 1 lone pair plus 3 bond pair, it is 4. That is again sp3. So the odd one out is A part, that is A is going to be the correct answer. Okay. Next we have students. Next is, find the molecule with the least bond angle. Least bond angle you have to see. So more is the hybridization, angle is going to decrease, because we know that sp, sp2, sp3, right? Angle here is what it is maximum, then it is decreasing, right? Oops, I don't know why my board is always in the mode of dancing, right? So here it is BeF2. So if you talk about BeF2, here it is Be, right? This is F, this is F, right? So here angle is 180 degree. CH4, the angle is 109. SF6, that is the octahedral shape. Here the angle will be 90 degree with each other. BF3 angle is 120 degree, right? Because it is trigonal planar. So they are saying with the least bond angle, that is going to be, find the molecule with the least bond angle. Least bond angle is going to be SF6. So answer is going to be C is the correct, because in SF6 you have 90 degree angles, no? 90 degree, 90 degree. There are also 180 degree angle, but there is also 90 degree angle, right? Okay. Next we have, in a regular octahedral molecule MX6, the number of XMX bonds at 180 degree is. Okay, everyone? In a regular octahedral molecule, that is MX6, the number of XMX bond at 180 degree is. For this, that is why I was saying that this thing is important for you to understand. XMX bond, XMX1, XMX2, XMX3, 1, 2, 3, 1 set, 2 set, and third set, right? 3 XMX. The number of this at 180 degree they are saying, na? At 180 degree you have 3. 1, this is the first pair, this is the second pair, and this is the third pair, right? So that is 3 180 degree angles you have here. Got it? Understood na how I am saying? 1 between these two, second, this is the third one. Okay, this is the third one. Okay. Next is MOT, right? Let us understand MOT, that is molecular orbital theory, which you will feel as compared to hybridization, you will find it simple because only electronic configuration is required here for the molecular orbitals. So what exactly happens here? Atomic orbitals combine to form molecular orbitals, right? So we are going to see how molecular orbitals are going to behave here, right? So MOT is basically given by Hund's, and this you don't have to do. Just remember, two atomic orbitals combine together to form anti-bonding and bonding molecular orbital, right? Just give me a second. I think AC is too high. Okay. Anti-bonding molecular orbital and bonding molecular orbital. So like atomic orbitals, the filling of electrons in the molecular orbital is governed by these the principles, where we should understand that the energy of bonding is always less as compared to anti-bonding. Anti-bonding orbitals are unstable as compared to bonding molecular orbitals. Now, if you talk about the conditions here, you don't have to go through them in detail, just focus on the concept and then directly switch to the questions, right? I'll give you a conclusion part of this, that basically they should align together like 1s, 1s and 2s, 1s, right? How they are going to combine, 1s will combine with 1s, 2s will combine with 2s, right? So combining AO should be comparable energy. Combining atomic orbitals must overlap to large extent. Greater the overlap, maximum overlap means good molecule will be formed here. A stable orientation should be good, right? Now, according to wave mechanics, like atomic orbitals, like how they are going to combine with each other, let us talk about that. So basically what happens, here you have positive and here also you have positive. When they combine, with positive overlaps positive, negative overlaps negative, then you have the formation of bonding molecular orbital, right? That is the positive overlap, which is the addition of the wave functions, right? But if you have one positive, this is negative, this is negative, this is positive. Now the positive part is combining with the negative part, right? Basically, it is going to cancel each other. That is why it is called anti-bonding molecular orbital. What it is called? Anti-bonding molecular orbital, which is represented by this star whenever you are making anti-bonding. This is like a constructive thing, right? This is a destructive wave function, right? That is how we can understand this, right? With the help of wave mechanics, right? Amplitude has basically decreased. So two things can happen, either addition or subtraction. With addition, you will have the formation of bonding. With subtraction, you will have the formation of anti-bonding molecular orbital, right? Now here, if you talk about, let's say 1s, 1s from one atom, 1s from other atom, they will combine, one bonding, one anti-bonding will be formed, right? Similarly, 2s will combine, this is 1s, similarly 2s will combine, 2p will combine, right? Hence, we are going to have sigma 1s, sigma star 1s, here should be star, sigma star 1s. We will have sigma 2s, sigma star 2s, sigma 2pz, sigma star 2pz. It's a very, very important thing to note down that this is sigma 2pz. This is pi to px, pi to py. So, pz forms sigma bonding, axial overlapping, but px and py will have pi overlapping, that means sideways overlapping it will have, right? So, this thing you need to remember, sigma 2pz, pi 2px, pi 2py, right? Okay, always remember 2px and 2py are going to have equal energy, they are degenerate orbitals, right? Okay, so this is 1s, this is 2pz. How it is going to form? 2pz is going to form axial overlapping, axial overlapping. This is basically taken as okay, all the scientists, it's not like 2pz only will be sigma, right? It is a assumption that we took, right? Okay, so here it is anti-bonding and this is bonding, right? This is 2px, they will show sideways overlapping, that is why it is pi is formed here, right? Now, let us see, all of this was the simple conceptual knowledge that I gave you. Now, what is important for your exam? We are going to talk about that. That is 2-3 very, very important things we are going to talk about. First is the electronic configuration here. The electronic configuration, if you see, always remember one thing, that whenever you have from 1 to 14, what I have from 1 to 14. Always remember, in case of 1 to 14, you will always have sigma 1s star, sigma 2s star is same. Difference is here. In 1 to 14, you will have 2, 1, 2, 1. That means, firstly, you will have, this is 2, this is in the category of 2, this is 1. This is 2, this is 1. That means you will always have 2, 1, 2, 1. That is how you are going to write it. Right, to make the, when you are solving the question, to make it easy for you, right, you have to write it in this way, 2, 1, 2, 1, 2, 1, 2, 1. That is how you are going to write it. Now, next is, whenever we are going to talk about more than 14, we'll take, it exceeds more than 14 electrons are involved. Answer is going to be 1 to 2, 1, right? This is 1, 2, 2, 1, right? That means the energy profile diagram is going to be 1, 2. I'm just going to draw it with the different pen. 1, 2, 2, 1. And you will see how it is going to change the bond order, the paramagnetic character of the molecule, right? Okay. Now, next thing what they ask you is bond order. That is number of bonding minus number of anti-bonding. Here also I am going to give you an amazing trick. Number of bonding electrons minus number of anti-bonding electrons divided by 2. That is the original formula that you should always remember. Now, let us see other important factors here. If the bond order is 0, it means the species does not exist. It does not exist, right? Bond order of 1, 2, 3 corresponds to single, because H2 has only one bond order. O2 has 2 bond order, that is why it is double bond. N2 has 3 bond order, that is why it is triple bond, right? Bond order, when it is increasing, stability of the molecule will increase and bond length will decrease. If a molecule is 0.5 bond order, then it is very unstable species, right? Now, magnetic properties. If you have paired electrons, that is diamagnetic. If you have even one single unpaired electron, that is paramagnetic, right? Now we are going to see the table here, how we are going to solve things. Firstly, I'll see this table, right? Firstly, we are going to see this table, then this one, then I'm going to tell you how to solve the questions, okay? Just like you did, you devoted time to VBT, VSEPR, and hybridization and shapes. Now you have to devote time here for next 10 minutes, okay? That will really, really help you. If you are ready for that, let us start that. If you are ready for that, let us start that. Let me know in the comment section if you are ready. If you are ready, then let's start it without wasting any time here. Here it is H2. So in H2, what you have to remember, in H2, it is sigma 1s2. Firstly, in H2, remember one thing, that H2 is what? Firstly, you have to know the total number of electrons here. That is the how to solve these kind of questions. H2 is 1 electron in 1 hydrogen, 2 electrons in 2 hydrogen. Now it is less than 14, so it will be 2 1 2 1. You don't even have to go to 2 1 2 1, because if you talk about the electronic configuration, it will fill it like this: sigma 1s 2, sigma star 1s. It will have 0. 2 electrons are filled in sigma 1s only. So answer will be sigma 1s2. If you have you have H2 positive. That means you had 2 electrons, but positive means you are taking out 1 electron here, that is -1, it is 1 electron. So that will be sigma 1s1 only. Right? H2 negative. What is H2 negative? H2 negative means you had 2 electrons for H2 plus 1 electrons, because we are adding 1 electron here, that is total 3, right? Now here it is sigma 1s2, sigma star 1s1, right? Sigma 1s2, sigma 1s2, that is 2 electrons here, sigma star 1s1, right? Understood? That is there. It is going to give us 0.5. It is going to be 0.5. That is, it is going to give us bond order. I'll tell you how we are calculating the bond order, right? So we had three things. H2 was sigma 1s2. This is sigma 1s1. This is sigma 1s2, sigma star 1s1. It is following Hund's law. All the simple electronic configuration rules are also applied here, right? Bonding electrons are 2. So 2 minus 0 by 2 is 1. So bond order is 1. 1 minus 0 by 1 is nothing but, by 2 is nothing but 0.5. So that is why H2 positive does not exist. It is unstable molecule, because bond order is 0.5. Here it is 3 minus 1. Sorry, not 3. This is 2 na. Bonding minus anti-bonding divided by 2, that is 1 by 2, that is 0.5. That is the reason H2 negative also does not exist. Okay, it is unstable molecule, right? Now let us see O2 and F2 here, right? If you talk about O2, let us talk about O2. If you talk about O2, O2 we know that O2 is how many electrons? Oxygen is 8, atomic number is 8. In one oxygen you have 8, in two oxygen you will have, I am not talking about O2 2 negative, I am just talking about O2, right? So O2 has 8 plus 8, that is 16 electrons. 16 electrons. Now I am going to give you a very important trick. I am just going to solve it on the next page. It has 8 plus 8, that is 16 electrons. Now two things are possible here. In fact, three things are possible, right? Three things are possible. Either you can solve it by, longest method is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, da. Okay? Don't do this, right? We know that when the number of electrons are greater than 8, always and always you are going to have, always beta, always and always you are going to have electrons in KK shell. Okay, what is ma'am KK? Ma'am, what is KK, ma'am? This is KK. Sigma, sigma star, sigma, sigma star. That is why in KK you have 8 electrons. Sigma 1s you have 2, sigma star 1s you have 2, sigma star sigma 2s you have 2, sigma star 2s you have 2. So total you have 8 electrons always. So it is just subtract out of this 16, just subtract 8 electrons, that is from the kk. 1s, 2s, 1s star, 2s star, we have already subtracted, we are left with 8 electrons. Now, because it is greater than 14, here it will be, it is following 1, 2, 2, 1. You don't have to write the electronic configuration, just write 1, 2, wait a minute, 1, 2, 2, 1. This is what you are going to write here. 1, 2, 2, 1. Now here you have 8 electrons, that is how to write, how to fill 8 electrons and degenerate. 1, 2, 3, 4, 5, 6, 7, 8. Now you can say 2 unpaired electrons in O2. Second thing is what they will ask you, in which orbital you have unpaired electron. So we know that this is nothing but this is Z, right? This is sigma 2pz. This is sigma star 2pz. This is pi 2px. This is pi 2py. This is pi star 2px. This is pi star 2py. Okay? Understood? When you're writing the electronic configuration, you might do mistake, but in this you will not do any mistake, right? If they ask you bond order here, bond order, bonding minus anti-bonding, but ma'am, we have not written kk, ma'am. Now very simple again. 2 will cancel 2, 2 will cancel 2. That means kk, that means 1s is going to cancel 1s star, 2s is going to cancel 2s star. So you don't have to worry about those electrons. So that is why just focus here. Here in the bonding, that is 1, 2, 3, 4, 5, 6. Anti-bonding you have 2 divided by 2, that is 4 by 2, 2. That is why oxygen has double bond. Right? Now, do we have even simpler method here? Yes. So what is that even simpler method here, ma'am? That is, remember, if you have 14 electron, the bond order is 3. That's it. Okay. Now, when it is decreasing, it is 13, 12, 11, 10. It is increasing 15, 16, 17, 18. Okay. You are just going to subtract 0.5 from there. This is subtract 0.5, it will be 2.5, 2, 1.5, 1. It is 2.5, 2, 1.5, 1. That's it. Okay. So you can easily also directly also calculate this, that it is having 16 electrons, so bond order is 2. Right. So easily also you can calculate that. Right. Now they were talking about O2 2 negative. O2 2 negative means you are adding 2 electrons. That means total you have 18 electrons. 18 minus 8 means you have 10 electrons. Right. Now I'll tell you how directly I am doing this. Right. So I'll do that on the next page. O2 2 negative. O2 2 negative. O2 means you have 18. O2 2 negative means 18 electrons, minus 8 means you have 10 electrons. How I did that? I subtracted kk. I subtracted sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Right? Now, these 10 electrons, I'll fill this in, because in O2 2 negative, always remember in the ions, you can't see the electron that are actually present there. These are the actual electron that are present. You have to see O2 2 negative is formed from O2. So in O2 you had 16 electrons, which is greater than 14. That's why I am applying 1, 2, 2, 1. 1, 2, 2, 1. That means 1, 2, 2, 1. Now fill the electrons. 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is why it is diamagnetic. Right? Electrons are 18. That is why bond order is 1. Okay, bond order is 1. You can also calculate 1, 2, 3, 4. This is sigma star. This is also star. This is also star. So it will be 1, 2, 3, 4, 5, 6. 6 minus 4 by 2. That is nothing but 1. Either ways you can calculate. Right? Now here, Ma'am, O2 2 positive. Can you tell me that? Or let's say O2 positive. 16 minus 1, that is 15 electrons are present. Out of 15, I'll subtract Kk, that is 8 electrons. I'll subtract. That will be 5, 6, 7 electrons we are left with. In the original O2 molecule, you had 16 electrons, so it will follow 1, 2, 2, 1 only. 1, 2, 2, 1, it will be 1, 2, 2, 1. This is star, and this is also star. 7 electrons you have to add, 1, 2, 3, 4, 5, 6, 7. It is paramagnetic with 1 unpaired electron, right? O2 is paramagnetic with 2 unpaired electrons. Here number of electrons are 15, right? So here bond order is going to be 2.5. Okay? Understood? Understood, students? Similarly for F2. F2 is what? F2 we know that 9 plus 9, it has 18 electrons. So bond order will going to be 1. Why? Because from this trick 18 means 1. Okay? Or if you want to understand the electronic configuration also, this is 18. Subtract Kk. So it will be 10 electrons. 10 electrons. Originally it has 18 electrons. That means 1, 2, 2, 1 will be applied. 1, 2, 2, 1. How to fill the electrons? 10 electrons you have to fill. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is no unpaired electron. That means it is diamagnetic. This is what they have written here. Right? Okay. Is there any query? Any problem here? Okay? Any problem? Any problem? Wait a minute. That is 7 plus 8. Okay. Acha, I'll give you one question. I'll give you that question once we complete the previous year questions here. In the end, I'll give you that. Okay? In the end. And what was this? This was nothing but this was the diagram of N2. You don't have to make this in the exam. Just do what I told you directly. Okay? With that, you can easily solve. During the change of O2 to O2 2 negative, we have just done that. O2 to O2 2 negative, O2 negative. The incoming electrons goes to which orbital? O2 is what? O2 is 16 electron. 16 minus 8, that is nothing but 8 electrons you have to fill, right? 1, 2, 2, 1, 8 electrons you fill. 1, 2, 3, 4, 5, 6, 7, 8. Now, incoming electron, that means when you gain 1 electron here, that will be filled in this particular case, that is nothing but it is pi 2px antibonding, right? So answer is going to be C is the correct answer, right? Okay, understood? Yes. Next is, according to molecular orbital theory, which of the following is true with respect to Li2 positive and Li2 positive and Li2 negative? Okay. Unstable stability you have to tell here. Now Li2 is nothing. This is Li2 negative. This is positive. Okay. Hydrogen, helium, lithium. 3 into 2 is 6. 6 minus 1 is 5. Okay. This is 6 plus 1 is 7. Right? Okay. 5, this is 7. Here it will be because you don't have, if you have greater than 8, then you can subtract 8 here. So you have to fill in Kk also. Sigma 1 is 2, sigma star 1 is 2, right? Sigma star 1 is 2, 1 is 2, sigma 2 is 2, sigma. Now, 5 electrons you have to fill. See, if you write all the electronic configuration, sigma 1 is, sigma star 1 is, sigma 2s, sigma star 2s. Similarly, write it here. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Now fill the electrons. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Right? So now here what you can see, bond order is going to be bonding minus anti-bonding. So in bonding you have how many electrons? 3. Anti-bonding you have 2 electrons divided by 2, that is 1 by 2, that is 0.5. Okay, which is unstable. Here you have bonding, you have 1, 2, 3, 4. Anti-bonding you have 3 divided by 2. Wait a minute, both are unstable, na? 1, 2, 3, 4 minus 3. 1, 2, 3 minus 2, yes. So this is also 1 by 2. This is also coming out to be 0.5. So both are unstable. So answer is B is the correct answer. That means they do not exist. Right? Arey, how come both are stable? Hydrogen, helium, lithium. You're losing one electron. Wait a minute. 6 plus 1, 7. Okay. 3 minus 2 divided by 2. It should be unstable only, right? But I'll see this. If there is any change that we need to do here, right? Okay. But it should be unstable. Okay. Then next question is, among the following molecules or ions, which is diamagnetic and has shortest bond length? Diamagnetic, firstly you can see, right? Diamagnetic, if you talk about, this is definitely paramagnetic, we have just done, right? N2 2 negative, right? If you talk about O2 2 negative, that is definitely diamagnetic, right? And C2 is what? C2 is carbon is 6 to 12 plus 2 electron, that is 14 electrons, right? So originally C2 has 12 electrons, so it will be 2 1 2 1 2 1 2 1. Electrons that you are going to fill is 14 minus 8, kk shell you have to subtract, 6 electrons, 1 2 3 4 5 6, right? So it will be diamagnetic as well, right? Talking about N2 2 negative here, N2 is what? 14 electrons, right? 14 plus 2 electron, that is 16. This is very important. What you have to use, this is what I was telling you, right? What you have to use, here students will use 1 to 2 1, but you have to use 2 1 2 1. Can you tell me the reason behind that? Because originally it is formed from N2. N2 has 14 electrons. So that means it will originally get added to that. Na? So it will be 2 1 2 1. That means 2 1 2 1. And if you subtract 8 electrons from here, you will be left with 8 electrons. Right? So when you fill the electrons, 1, 2, 3, 4, 5, 6, 7, 8. Right? It is paramagnetic. Okay, 2 1 2 1. Wait a minute, 1 to 2 1. Okay. Okay. So answer will be these two are diamagnetic in nature. From these two you have to tell which has shortest bond length. Okay. If you talk about this, it is like you have to calculate the bond order here, right? This electrons, this is carbon 2, this is 14 electrons, that is 3 bond order. It is 14 plus 2, 16 electrons, that is 2 bond order, right? It is 16 electrons, again 2 bond order. This is 16 plus 2, 18 electrons, that is 1 bond order. So that means this is going to have the shortest distance. It is going to have triple bond here, triple bond order, right? So answer is going to be D is the correct answer, which has which is diamagnetic also, which has maximum bond order also, right? Okay. Acha, I told you that I will tell you one thing in the end, that is NO positive, right? NO has 7 electrons, oxygen has 8 electrons, that means total 15 electrons. When you subtract 1 electron because of this positive, it is going to have 14 electrons. Now the question is, ma'am, it will use 1 to 2 1 or 2 1 2 1? 1 to 2 1 or 2 1 2 1? This is very important, right? 1 to 2 1 is for more than 14. 2 1 2 1 is for less than 14 or equal to 14. See, ma'am, 2 1 2 1, ma'am. Why? Because, ma'am, it is 14 equal to 14. But originally NO had 15 electrons, which is more than 14. That is why we will use 1 to 1. 1 to 2 1, not 2 1 2 1. Okay? Originally you have to see. So it will be 1 2 2 1. So you have to use 1 to 2 1 here. So here it is. Out of 14 you subtract KK shell. So that is 6 electrons you have to add here. 1 2 3 4 5 6. Okay, so this thing is also very important for you to understand. Last topic of today's dipole moment, right? In dipole moment, remember one thing, it is actually according to the directions, right? Okay, it is a vector quantity, so direction matters here. Now this is represented by mu, this is the charge, this is the distance, right? You don't have to do any numerical here, right? What you have to understand is always it is from less electronegative to more electronegative. Always from less electronegative to more electronegative, or atom to lone pair. Always the arrow is towards it. According to that, we will try to understand different orders of dipole moment. This all you don't have to do, right? Okay, let's understand with the help of fun question here. Although CO2 has no dipole moment, SO2 and H2S have considerable dipole moment. Why? So you have to know the shapes here, right? If you don't know the shapes, you won't be able to understand this. CO2 is this thing. Can you tell me why this is the shape? Okay. Carbon, ma'am, it is 14, group number 14, outermost electron is 4. Ma'am, definitely it is going to have multiple bonds because it is attached to oxygen, which is neutral. So that means 4 electrons are involved. 1, 2, 3, 4. 4 electrons are involved in bond pair. 0 lone pair you will have. That is why total it will be, what is the hybridization? 1 sigma, 2 sigma, 2, that means sp hybridization, that means linear. That is why this is the shape. That is a linear shape. Okay. SO2 and H2O we have drawn before also. SO2 is 1, this thing, right? And H2O is, this is oxygen, this is 1, this is 1 lone pair, another lone pair, 1 hydrogen, another hydrogen. Now what you will see here is, it is always from less electronegative to more, less to more. This is also less to more. This is also less to more. Okay. Now tell me one thing. Across the period, electronegativity increases. Down the group, it decreases. That is why oxygen has more electronegativity. Right? So, sulfur to oxygen, sulfur to oxygen. Always from atom to this. Atom to lone pair. Always from atom to lone pair, atom to lone pair. More electronegative to, less electronegative to more, less electronegative to more. Now here, because both the dipole moments will cancel each other because on both sides you have symmetrical bonds. So here mu is equals to 0. In this case, you can't say, ma'am, here also it will cancel. Yes, the resultant will be this one, but this value and this value is different. This is from atom to lone pair. This is the resultant of S double bond O. They can't be exactly equal to each other. Right? So mu will not be equals to 0. And this will have maximum dipole moment if you say, because here resultant is going to go upwards, here also resultant is going to go upwards. So it is in the same direction. So here also mu is not equals to 0. That is why they have considerable dipole moment. Okay? Understood? Yes, students? I hope so you are able to understand all these things. Right? Okay. So now, what is important for you to understand that, we have done chemical bonding. We have done everything here. we have done important concept, we have done questions. But ma'am, how to do practice? That is the main task, right? We are just very near to our JEE mains, right? So for that, we have something for you. And what is that something? Let us see that. Now, if you see this here, we have JEE Mains Attempt 2 crash course for you. In this crash course, what exactly we are providing, right? Because we have very less time, so we have to utilize that time in a good way. So that's why we are providing you targeted revision, focus on high score, speed and accuracy boost will be there by solving a lot of problems, and we will also have doubt sessions, smart practice, right, with the help of the teacher guidance. Mock test and the analysis will be there. Every week there will be mock test and along with the analysis. The batch has already started from 12th of March. It has already started. So don't miss the classes, right, and enroll yourself right away, right, because the moment you are procrastinating, you are losing what? Let us see. You are losing these many sessions, right? Now it is like you must have lost, like if you it's 12, right? So already 12, 13, if you consider 14 also, so already 9 sessions you have lost, right? So if you keep procrastinating, you are going to lose. It's not like you will not have recordings of that. You will have. But why to have watched so many recordings? Why not to attend the live sessions? Because you're already so much occupied here. From session 1, let us see, this is session 1 to session 4. Actually, you have 4 sessions in a day. So it is 4 into 3, 12 classes you have already lost, right? So it is 3 to 4:30, 4:45 to 6:15, then 6:45 to 8:15, 8:30 to 10, right? Continuously the classes are going on here. So you don't have time to watch recording. Why we have given you time before 3 p.m.? For your practice, for your self-study, so that you can also ask the doubts in between the class. In the class, you will have live classes, doubt solving, leadership quizzes, practice questions, DPP's previous year question sessions specially for you. After the class, you will have handwritten notes, assignments, ready-made recording, replay recordings, right? Pedagogy app you will have, P-Buddy. By the way, in my opinion, you will not be able to use this. Reason I'll tell you, because already you are so much occupied, but still, let's say you are weak in some one particular section, right? Now, you can also go and watch the pedagogy app and VBuddy where you are provided with small bits, right? You are provided with one shot recordings also, that okay, this was taught in the class, but I also want to do that chapter. I'm also weak in that topic. I also want to finish that topic because that is in my target list today. So you can easily do that as well. This is the additional thing that is provided to you, right? Then you have exclusive Telegram groups for community discussions with master teachers, right? Especially for the batch students. Exclusive benefits are master teachers expertise in JEE, then regular performance tracking through tests and assignments, access to high quality study materials and notes. Yes, that is there. Past year question analysis for JE. According to that, only our mock tests are set. Batch will end on 20th of April. After that, what we are going to see, let us see. Post JE Mains 2 will solve multiple exam readiness, right? Printed JE previous year question books, right? For your advance also, right? Targeted study sessions, right? Exclusive test series, right? For your other exams like VIT right? And other exams, right? Now you have this particular thing here. 3 batches we have. Basically it is 1 batch only, but by paying extra you can get extra additional things. If you just want to get enrolled to JEE Mains 2 and VIT then simply buy crash course. If you also want to focus on KCT Commid-K tests, right? So that is provided to you in crash combo, right? In Crash Pro, you will be provided with JEE batch, VIT batch, that means classes, KCT Commid-K test, printed JEE previous year question books delivered to your home, that is also provided to you in Crash Pro, right? Understood? Now all these things are provided to you. Let me just show you where. Okay, batch prices. Crash Prime is 999. Crash Combo is 1999. Crash Pro is 2999. And I will always advise the student to purchase Crash Pro if you actually want to focus on previous year question books, right? You don't have that, and you also want to prepare for KCT and Commid-K as well along with this, right? Okay, now here these are the features. Master the JEE with Vedantu previous year question book that is provided in JEE combo, right? In JEE Pro batch, right? That is already provided, right? Okay, these are the features of this book. That completion. I don't know if I'm pronouncing it right or not, because I think sometimes I fumble in between. Right, of 2 year JEE means previous year question. That means compilation. This is right. Sometimes this happens. Compilation of 2 year, right? JEE means questions. That will be a lot of questions considering the shifts that you have. Full year recorded lectures to clear your doubts. Detailed solutions provided for every question, right? Enhanced practice and revision. Time management focus to approach, like how to manage the time. Everything is given in this particular book, right? And also you'll be able to manage everything here. Now, let me just show you this particular batch. The link is in the description. You can go and check that out, right? Okay. I think this I was telling you about the book, right? So this book beta, if you want to purchase this individually, that is at 999. But if you purchase this along with the batch and KCET and Commid-K and VIT and JEE and along with this previous year question book delivered at your home, that will be 2999. So I think that is a more beneficial approach, right? Okay, so that is my advice to you, right? That's it for today. I hope you really liked this session. If so, then leave the like button and comment box also. I want you guys to fill it with comments here, right? Next lecture I'll be taking is coordination compounds. So I'm waiting for all of you to join in coordination compounds as well. That is a lengthy chapter as compared to chemical bonding, and we are going to deep dive into that particular chapter as well. So if you really like the video, then I want each and every student to like this, share this and comment down that what were your reviews on this. Till then, bye-bye. This is Diksha Kaushal signing off. Bye-bye.